Everyone, thank you for joining the session. Good evening. Let me just take you through a short introduction for Mr. Chirag S, who's joined us today. So it gives me a great pleasure to welcome you all to today's webinar. We are truly honored to have with us Mr. Chirag S, Principal AI ML Engineer at Takeda, as our distinguished guest speaker. With over 9 years of experience in data science, analytics, and machine learning, Chirag sir has made impactful contribution across multiple industries, including catastrophic modeling, insurance, travel, healthcare, and semiconductors. His exceptional work includes building large-scale data pipeline processing billions of records, deploying high-performing ML models, and developing production-ready AI solution at top global organizations like Walgreens Boots Alliance and Micron. Chirag sir also holds, I'm sorry, um, excuse me. So Chirag sir also holds a dual master's degree, one in computational data analytics from Georgia Tech, a top 10 globally ranked program in data science, and another in operations research from Northeastern University. We are delighted to have you, sir, you are sharing your knowledge and experience with us today. Let's give a warm virtual welcome to Mr. Chirag S as he takes us through today's insightful session. Chirag sir.
Thank you. Thank you so much, Rocky, for the introduction. And yeah, about me, let me just share my screen. So I can go ahead and share my screen. Yeah. So hi. So I'm going to start the presentation now. So basically about me is that I'm a data science professional with 9 years of experience in data science and analytics applied to 5 different industries in USA and India. The agenda is such that I'm going to talk about my career journey so far for 5 to 10 minutes, and then I'm going to talk about the different aspects of a data science career, and then I'm going to talk about and then I'm going to leave the floor open for Q&A in the last 10 minutes. So a bit about myself: I have a bachelor's degree in mechanical engineering from Manipal Institute of Technology, India, 2014. Master of Science degree in operations research from Northeastern University in Boston, and a second Master of Science in Computational Data Analytics from Georgia Tech, which I graduated in August this year. I have 9 years of full-time experience in data science and analytics applied to 5 different industries in US and India, like catastrophe modeling, insurance, travel, semiconductors, and healthcare. And my core skills are in data science, AI, ML, and statistics. My professional journey in USA started as an analyst at Aon, where I worked on probabilistic modeling and statistics applied to the catastrophe modeling industry. And then I worked as a data scientist at Advent Group in the insurance industry and a senior marketing analytics analyst for Holland America Line, followed by which I worked as a senior data scientist at Walgreens Boots Alliance. This was a Fortune 16 healthcare leader with an annual revenue of USD 140 billion, and mostly worked with in developing and deploying credit card propensity tool prediction framework using XGBoost multi-class classification model. And after that, I moved to India last year, and I worked as a staff engineer, data scientist at Micron Technology, which is a global leader in semiconductor manufacturing industry. And currently, I'm working as a principal AI/ML engineer at Takeda, which is a global leader in healthcare in Bangalore. So about data science career, I can start with what is data science. So data science is an interdisciplinary field that uses science, algorithms, and systems to extract knowledge and insights from structured and unstructured data. We apply techniques from mathematics, statistics, computer science, and information science to analyze, model, and interpret complex data, aiming to make informed decisions and predictions. For example, building a framework to analyze customer behavior and measure the impact of changes in customer behavior on a company's incremental annual revenue. Now, why do companies hire data scientists? Why are data scientists needed today? Because data scientists bring a unique blend of skills in statistics, machine learning, and computational tools, enabling them to analyze complex data sets, identify patterns, and predict trends. Here's how data scientists add value to a company's incremental revenue. By improved decision making, data scientists use predictive analytics and data modeling to provide actionable insights, enabling companies to make more informed decisions. They enhance the customer experience. Through the analysis of customer data, data scientists can help companies understand their customers' needs and preferences better. Operational efficiency. Data scientists apply their skills to streamline operations, reducing costs and improving productivity. New product and service development. Data science can drive innovation by identifying new market opportunities and trends. By analyzing data from various sources, data scientists can uncover unmet customer needs or emerging trends, guiding the development of new products or services that meet these needs, thereby generating new revenue streams. Risk management. Predictive models and risk analysis developed by data scientists can help companies anticipate potential issues and mitigate risks, like in sectors like finance and insurance. This capability can lead to more accurate pricing, better risk assessment, and fraud detection. Targeted marketing and sales strategies. Data scientists can use customer segmentation and predictive analytics to design targeted marketing and sales campaigns. By focusing efforts on the most promising prospects and customers, companies can therefore achieve higher conversion rates, increase upsell and cross-sell opportunities, and ultimately boost revenue and competitive advantage. In a data-driven world, companies that can quickly interpret and act on data insights can outperform their competitors. Data scientists enable companies to be more agile and innovative, responding rapidly to market changes and customer demand. So let me continue with what is machine learning. So machine learning or ML is a subset of artificial intelligence, AI, within data science that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. What it means is that it focuses on the development of computer programs that can access data and use it to learn for themselves, identifying patterns in data and making decisions with minimal human intervention, making predictions with human-like accuracy with minimal human effort. For example, if you build a machine learning model to automate the classification of different types of insurance claims, like I did in one of my projects at Amman's Group, then there are different types of machine learning, and they are supervised machine learning, unsupervised machine learning, semi-supervised machine learning, and reinforcement learning. So, what is supervised learning? Supervised learning is a type of machine learning where the model is trained on a labeled data set. This means that for each data point in the training set, the desired output or label is known. The model learns to predict the output from the input data during the training process. So the two different types of supervised learning are classification and regression. For example, classification is classifying input data into different target categories like categorical outcome. For example, identifying spam emails, recognizing handwritten digits, facial recognition, regression. And the second type is regression, predicting a continuous or quantitative outcome based on the input variables. For example, predicting house prices based on features like location, size, and condition. Unsupervised learning. Unsupervised learning involves training a model on data without labels. The goal is for the model to find patterns and relationships in this data on its own. For example, clustering, customer segmentation, grouping similar news articles, organizing computer clusters, association, market basket analysis. For example, customers who bought X also bought Y, recommendation systems, dimensionality reduction, data compression, feature extraction, reducing noise from data. Semi-supervised learning. Semi-supervised learning sits between supervised and unsupervised learning. So this type of learning uses a small amount of label training data along with a large amount of unlabeled data for training. This approach leverages the small amount of labeled data to guide the learning process in the larger unlabeled data set. Semi-supervised learning types and the use cases are image recognition, labeling images when only a few examples have labels, language translation, improving translation models when there's limited access to translated text pairs, speech analysis, classifying speech when there's limited labeled audio data, and reinforcement learning. Now, reinforcement learning is a type of machine learning where an agent learns to make decisions by taking actions in an environment to achieve some goal. The agent receives rewards or penalties for the actions it takes, and it uses this feedback to learn over time. For example, a game playing AI that learns to play and excel at games like chess, Go, or video games, robotics, robots that learn to perform tasks like walking or picking up objects, personalized recommendations, systems that adapt to user preferences over time, like streaming services adjusting content recommendations, for example, Netflix or Amazon Prime Video. Here are 5 common types of data analytics jobs and skills required for each type of job. The first is data analyst. They analyze and summarize data, build reports, and dashboards. This job requires proficiency in SQL, Excel, Python, basic statistics, and data visualization tools like Tableau, Power BI, Matplotlib, and Seaborn. This is a common entry-level job with a bachelor's degree required. A data scientist. They pre-process, analyze, summarize, and visualize structured and unstructured data, build machine learning models, and recommend optimal decision making for companies. This requires proficiency in statistics, probability, linear algebra, machine learning, strong programming and data visualization skills, R, Python, SQL, Power BI, PySpark, Microsoft Azure, AWS, GCP, etc. And sometimes deep learning and reinforcement learning frameworks like TensorFlow and PyTorch. And for some roles, need knowledge of algorithms and data structures. Business understanding and knowledge skilled in cross-functional collaboration, effective communication, teamwork, and business stakeholder management. This is more commonly a mid-senior level job that's a bachelor's degree and 2 years of experience, but it can vary by company. The third one is machine learning engineer. They build, deploy, store, and maintain machine learning models. They need strong programming skills, knowledge of machine learning algorithms, understanding of data structures and algorithms. This is mostly a mid-senior level job, like the data scientist. Then the fourth is the data engineer. They build efficient data pipelines, collect, store, and ingest data, process and move raw data into databases. They focus on big data technologies, ETL tools, databases, and scripting languages. Can be both entry level and mid senior level. And the fifth is the business intelligence analyst. They build data models, dashboards, reports, maintain warehouses, communicate with business stakeholders. They need skills in BI tools, data warehousing, and data modeling, along with a strong business acumen. It's a common entry level job with a bachelor's degree. So, there are 3 learning paths for aspiring data scientists. The first one is the analytical tools learning path. This path focuses on the quantitative methodology, how to select, build, solve, and analyze models using methodology, regression, forecasting, data mining, machine learning, optimization, stochastics, and simulation. This focuses on learning statistical software like R and SAS and advanced statistics, predictive modeling, operations research, and data visualization tools. The second path is the business analytics learning path, the business focused data scientist. This path is focused on the understanding, framing, and solution of problems in marketing, operations, finance, management of information technology, human resources, and accounting to develop and execute data science and analytics projects within businesses. This focuses on the business part of machine learning. And the third one is the computational data analytics learning part of big data, ML, and AI focused computer scientists. This path explores a deeper understanding of big data, including how to acquire, pre-process, store, manage, analyze, and visualize large data sets. Dive deep into programming in Python, data visualization, machine learning, deep learning, and reinforcement learning frameworks. algorithms and data structures, and computational theory. So this is a typical data scientist career progression in large companies in industry. You start off as an associate data scientist, then move to a data scientist, then a senior data scientist, a staff data scientist, then followed by a principal data scientist, then a manager data science, senior manager data science, director data science, senior director data science, and then a C-level executive like a vice president or a senior vice president. Of course, this is a bit slower as this is in a large company, but in smaller companies can be much faster. There are some free online data science AI ML learning resources like free coding practices and database, SQL, pandas, and algorithms, free Tableau, Power BI courses, linear algebra textbooks, statistics and probability for data science textbooks, and introduction to statistical learning with applications in R or Python, elements of statistical learning, advanced machine learning PDF, free A/B testing course by Google, Stanford algorithm specialization, deep learning by Ian Goodfellow, reinforcement learning and introduction. So now I'll talk about resume building advice for entry-level data scientists. So we should start by focusing on education and courses. Emphasize your data science education. Include relevant courses, projects, and the technologies or tools you've used, like Python, R, SQL, or machine learning libraries. Include projects and portfolios. Detail any personal, academic, or freelance projects relevant to data science. Provide links to your GitHub or portfolio website to showcase your work. Highlight relevant skills. List both technical skills and soft skills. Tailor these skills to match the job description you're applying for. Internships and part-time work. Any experience in internships, part-time jobs, or volunteer work where you've applied, data analysis, or handled projects can be incredibly valuable. Highlight these achievements and what you've learned. Formatting bullet points in a resume should be action-oriented. Start each bullet point with a strong action word like analyze, develop, implemented. Quantifiable achievements. Whenever possible, measure your results using numbers. For example, optimize the data pipeline, resulting in a 20% reduction in processing time. Relevance. Tailor your bullet points to emphasize the skills and experiences most relevant to the job you're applying for. Resume building advice more focusing on tailoring your resume and job application. Match the job description. Carefully read the job description and note the specific skills and experiences required and tailor your resume to highlight how your background aligns with these requirements. Create a different resume for every different type of job that you apply to. ATS-friendly keywords. Many companies use ATS to filter resumes. Use keywords from the job description throughout your resume. This includes technical skills, tools, and any specific methodologies you have mentioned. Customize your objective or summary. Adjust your resume's objective or summary to reflect the role you're applying for, mentioning how your goals align with the company's mission. Resume length. So candidates with less than 2 years of data science work experience, your resume should not be more than 1 page long. The average recruiter spends 6 seconds on an entry-level resume, so keep your resume short and concise. They make it
Rupesh, could you please go on mute? Thank you.
Yeah, and basically just keep your resume concise and limit it to 1 page for entry-level position. Proofread typos or grammatical errors can be a deal breaker. Proofread your resume several times and consider having someone else review it. Use a clean professional layout with a clear heading and readable font. Avoid excessive graphics or colors that may not be ADS friendly. So, and also here is a website called TLSQ.com, which uses AI to help you tailor your resume to different job descriptions. Then leverage LinkedIn and other professional platforms. These are networking advisors. Create a robust LinkedIn profile showcasing projects, skills, and education background. Sign up for LinkedIn Premium membership. Regularly engage with content from target companies and use LinkedIn's networking features to connect with recruiters and industry professionals. Personalize connection requests with brief introductions and your interest in data science roles within the company. Participate in hackathons and data science competitions. Join hackathons and data science competitions from Kaggle, or especially those sponsored by companies, professional organizations in India. These events are excellent opportunities to showcase your skills, solve real world problems, and get noticed by industry professionals and recruiters. Attend industry conferences and workshops. There are some common websites with entry level data science job postings: LinkedIn, Naukri, Indeed, Glassdoor, Monster, Analytics Vidya, Angel List for startups, Internshala for internships, Cut Short, Iris. Now I will talk about a simple way of how to explain how a decision tree classifier works. So imagine a regular tree that you see on the road. Now, if there's a regular tree upside down, that's how a data science decision tree looks like. There are different branches which split off into even smaller branches. The split starts at the tree trunk or root node, and at each split, there's a branch on the left and the branch on the right. Every branch corresponds to a different decision the model is making. This splitting is done in a greedy way, which ensures that the model always creates new branches, which will reduce the error made by the model on all data points, increasing model accuracy. This splitting continues until there are more than a minimum number of data points in each branch or node. So that's my explanation of how a decision tree classifier works in a simple way. And yeah, I'm done. And if you have any questions, please do ask.
Insightful, Chirag sir. So, if nobody has any questions, just wanted to thank you, Mr. Chirag, for taking us the time to share your invaluable insights with us today. You talk us, your talk was truly inspiring and gave us a deeper understanding of how data science and machine learning are applied in real world scenarios across industries. We gratefully appreciate the way you connected technical depth with practical relevance. It is it was both informative and sorry. On behalf of EduinX, we sincerely thank you for being our guest lecturer today and for enriching the session with your experience and thoughtful perspective. We look forward to staying connected and hopefully welcome you again for future sessions. Thank you again, and thanks for all the participants for joining today's webinar.
Sir,
Thank
could you
you.
please provide the slides?
Yes, yes. I'll provide it to the coordinator.
Sir, I have a small question. I'm a trained exchange engineer. Okay. So what is how should I?
There's some disturbance.
Okay, I just got this message. Like, can someone read out? Hello.
Yes,
Hello. Sir, am I
yes,
audible now?
yes.
Sir, actually, I'm a 10 years of experience with QA engineer. So, what should like my preparative uh, preparative path for being data scientist?
Can you send me your questions by email? I'll just share my email over here.
Yeah, sure, sir. Yeah, I'll send that in email. Thank you.
Yeah. Okay, thank you all. Yeah.
Thank you, sir. Thank you so much.